Okay. New lesson on slope. So find your page. That's labeled Math 8, Unit 4, Notes 3, Slope. Really, really, really important lesson. Okay, now we're getting into the real meat and potatoes of linear functions or linear equations. The two previous lessons were more or less introductions of the different types of functions, but for 8th grade's purposes, it is mostly linear functions, which we're going to do now. Okay. Believe it or not, you learned slope, and you learned slope by looking at unit rate, or rate of change. In 8th grade, it's called slope, or again, rate of change, and it's determined on a graph by comparing how the y value changes and the x value changes. Okay? So let's go through this little, step by step. Finding the slope of a line. Now, if you think of the word slope, slope is used for skiers. You can't move unless you have a slope. And a slope is the rate of change, where it's got to be like a hill. It's either going up or it's going down. So the words kind of go together. The steepness of a line is the ratio of the rise to the run. Okay, rise to the run. Rise meaning going up, and the run means going left or right. So rise to the run, or the vertical change to the horizontal change for this step. Okay? Guys, when you step on the stairs in a hallway, all right, when you put your foot down on the stair, okay, you are going on the rise and the runner. Like that would be the runner, and the rise would be your toe, where your toe is. So when you create a set of stairs, it does something like this. Okay, basically, this is the rise. Now, if you were to lay down a ruler along that, this would measure the rate of change. How did this change? Versus a set of stairs that might do something like this. If you were in like a park and they did those really long ones where you have to take 2 or 3 steps and then go. Okay? The rate of change would be quicker because it's steeper in this set of stairs versus this set of stairs, which is doing like a slow climb. Okay? So again, when you're going to hear this 1,000 times, it is the change in the vertical change, which is the rise, the measurement going straight up and down, versus the run, okay? So it's the rise versus the run, all right? And sometimes you can look at it this way, okay? The run is down here, and then we have the rise going this way. So it's the same thing. As long as you know, the rise is the piece that's going up, and the run is going left or right, all right? Very important. Rise over the run. Okay. To determine the slope of a line, you need to consider the direction or the sign of the vertical and the horizontal changes from one point to another. All right, so hint. A line with a positive slope. Let's take a look at this. If my brain is a scanner, I read from left to right. And technically we are sort of scanners. We do read from left to right. Our brain quickly scans or analyzes a piece of data, a piece of words, by going left side to right side. So when I scan this line with my brain, this line is going in what direction? To me, it's going uphill. So this is a positive slope. Okay? As numbers increase on the x-axis, the y values go up. Am I clear? This is uphill. Okay? Brain, think left side. You start on the left side and you go a little bit to the right. It's going uphill. Let's look at A. Try it. Is this an uphill line? So if my brain is a computer and I'm scanning from this side over, I jump on this line, I'm going uphill. So this line is, yes, is uphill. So it is a positive slope. Okay? The change is increasing, so it's positive. Right? This could be part of a word problem. Euclid's car wash charges. Is it increasing over time? Here's your time. Here's your money. As time increases to the right, what's the line doing? It is also increasing, hence a positive slope. Kind of get it? What do you think a negative slope is going to look like? If I had a graph here, this was x and this is y, my negative slope would be doing something like this. The line would be going downhill as I read from this side over. This would be a downhill slope. Whoops, sorry, downhill. So negative. Okay, we're going to get to that. So when we're clear on these, positive is going up to the right. Hill going up, hill going up. Do not tell me you're at the top of the hill and, oh, but this is an uphill. This is an uphill. No, it's not. If you're reading backwards, it's uphill. But we don't read backwards. We read from the left side to your right. And so from left side to your right, this hill is going downhill. All right? You're going to really have to know the difference. Okay? This is not the same kind of line as this or this, or the one up there. We good? All right. Next page. Here we go. Sorry, easily negative slope right here. A line with a negative slope. So looking at my brain, again, scanning, what direction is it going? Downhill. This is downhill. Write it on your paper. Downhill. So it is a negative slope. Be clear. You'd be surprised how many kids make mistakes on this. This is downhill. Don't pretend you're the little man over here and you want to climb the hill and go up. Nope, that's backwards. This is a downhill slope, negative slope. This one, what kind of slope is it? And if you think about it, as you increase going to your right, your numbers were, okay, on this line, they actually decreased, right? So therefore, this is downhill. Down, I can't spell down, D-O-W, downhill. So negative. Guys, don't write downhill in a test. You have to answer that is a negative slope. Okay, let's look at this one. This one is asking us for, what is the rate of change of the car speed from 10 to 15 seconds? Okay, so where's my seconds? It's on the bottom. Oops. 10 seconds is here. 10 seconds is here. And at 15 seconds, it was here. So at 10 seconds, what was the speed of the car? Okay, guys, I'm going to round it off to 45. It looks like it could be slightly above it, but I'm going to go with 45. So at 10 seconds, when x is 10, it was 45. All right, so this is my seconds, and this is my miles per hour. Okay? At 15 seconds, the car is what kind of speed? We're at 0. So it's come to a stop at 15 seconds. So the question you could say to yourself is, how is this time or speed changing per second? How many seconds are there? 1, 2, 3, 4, 5. So in 5 seconds, it went from 45 down to 0. So in speed per second, remember, we want to do speed per second. It was at 45, and in 5 seconds, it went to 0. So how much did it change per second? It changed 9, right? 9 miles per second. It decreased by. Okay? And we can see that it's a decrease, so it was slowing down by 9, and that's where we get the negative from, the 9 miles per second. Make sense? All right, we'll be doing a lot of these. You will get a hang of this, okay? You'll know exactly how to measure slope. Bottom, 2 special cases, and there's no way around this but just to know it. A 0 slope is a flat line. The line is horizontal, the slope is 0. Okay, notice, little man, there's no slope here. No slopes, 0, okay? This one, if the line is straight up and down, okay, straight up and down line, we can't measure slope. Excuse me, this is called, on a vertical line, it is called undefined. Weird, weird, weird. Yes, I know, but it's called undefined slope. Okay, undefined. So again, flat line. Think about a flat line. You're walking straight on a flat line. Is there a hill? Is it going uphill or downhill? And if you say no, then neither one. It is a zero slope. But this one, a straight up and down line, is what we would call undefined. And you'll see it mathematically in a minute. Okay, on the next page. Okay, now there is a way to determine, based on looking at a table of values, okay, what the slope of this line would be. So let's think about this. You only need two dots to make a line on a graph. You would just connect the dots and you'd have a line. So in this case, okay, the two dots here are, we have 2, 2, and the other dot would be 5, 4. So yeah, if I was to try to find them on a graph, my imagination would have me over at 2, up 2, and 5, over to 5, and up 4. And yeah, I got to, some sort of a line in my head. Is it a positive slope from the table? Well, if I look at this and go, okay, 2, 2 is lower than 5, 4. So the rate of change, if I want to compare the change in the y went from 2 to 4. So the y value went up, right? The y value from the first dot to the second dot goes up. So therefore, this will be a positive slope. Make sense? Kind of makes sense, going up. Okay, versus the top as well has increased. Okay, so let's take a look at this one. We have let's look at how our numbers increase here. -6 to -4 to -2 to 0 to 2 to 4. What's the x values doing as we go across? Isn't each x value going what? +2, +2, +2. To get to the next one, we went +2, and right there, +2, got to 4. What's happening in the y values? I get from -10 to get to -7, didn't I go +3? From -7 to get to -4, I went another +3. It's going to always have the same pattern. From -4 to get to -1, I added 3. From -1 to get to 2, it was add 3. 2 to 5. Nice. The positive ones are always easiest to see. 2 plus 3 made 5. Okay. So let's think about the slope here then. The rate of change is, things are increasing. I will come back. Okay. Back to slope. Okay. To determine the slope between coordinates like this, we actually are comparing how we have a change in the y values, okay, change in the y values over a change in the x values, okay? For future reference, the symbol, the Greek symbol for change is a little triangle here. So you make a little triangle here, and this means change in y over change in x. A lot easier to write this than do this. So just get familiar with this so you can recognize it. Change in y over the change in x. If you recall before, we were talking about rise and run. The change in the y is your rise, how you rise up on your axis, where the change in the x is the run sideways, left or right. So rise over run is the same thing as change in y over the change in x, and you make a fraction. Okay, so let's look at this one again. This is a positive slope. What occurred here? Got to remember, this is x, this is y of one point, this is x, and this is y of another point. The y values, how did the change occur here? It was by +2. So the change in y, it increased by 2. The change in the x is the denominator, and it increased by 3. So simply put here, the slope is 2/3, or 2/3. So we're going to go down to this one. And I want to do the same exact thing. The change in the y, how did y change? In this case, the y was changing by a +3. How was the x changing? Notice I want to make sure you're clear. It's the y change over the x change. Okay? And the x change was by 2. So this would be 3/2 the slope. All right? Let's go to the squeaky clean car wash. So if we compare the numbers here, the top value is always, when it's written in table form, this is the x, and this is the y. So on the x-axis, you would have at 5 minutes, it was $8. At 10 minutes, it was $13. At 15 minutes, it was $18, and so on. Get the idea? So as the time went up, so did the charge. Time increased in increments of +5, +5, +5, etc. We all agree. And how did the rate increase? Again, from 8 to 13, 13 to 18, and so on and so on. On the y-axis, it was an increase of 5 as well. +5, +5, +5. So the change in the y over the change in the x is simply y changes was by 5 and x changes by 5. Well, 5/5 is actually 1. So in words, as the time increased per minute, so did the charge increase by 1. So it's 1/1, which is just 1. Okay? All right, let's try this one. Take a look at this one. Our x changes, okay? Going this down the table is vertical as opposed to horizontal, but the change in x from -4 to -2 to 0 to 2 was simply by +2. +2 got you to 0. +2 gets you to 2. Let's look at the y's. -4 to 0 to 4 to 8. This side is +4. +4 got you to 4. +4 here got you to 8. So change in y over change in x. We have the change in the y is by 4. The change in x is by 2. 4/2 you can simplify to 2. So the rate of change here, or the slope here, is 2. Okay? All right, so those are positives. Those are 3 examples of looking at them in different formats and coming up with the slope or the rate of change. And they happen to be all positive. All right? A negative slope from a table. So let's take a look at this. So on the bottom here, we have 4. You would go to get to 2, it was -2. But on the top, from 1 to 4, it was +3. Okay? So having said that, if I'm again continuing with the change in y over the change in x, okay, change in y is by -2. The change in x is by +3. Well, we wouldn't write it as a -2 over +3. We simply write it as -2/3. And this is showing me that if I was to graph these, the point is 1, 4. Okay, 1, 4 over 1 up to 4. And the next point is 4, 2. And if you think about that on a graph, just a quick sketch, 1, 4 over 1 up 4 would be over here. And over 4 up 2. Over 4 and only up to 2, so clearly the line is going in a downhill fashion. Whoops, sorry, did not see that. Ooh. Okay, again, so the change in y, the y value is this part, and the change in x goes this way. All right, so let's try this one. The bottom one here. We got like halves in here. The x is easy. 1, 2, 3, 4, 5, 6. So what's the x column or values doing? +1 all the way, right? So the x values here is a +1. Excuse me. So we're going to do change in y over change in x. X is by 1. That's the denominator. How is the bottom? And what is the bottom doing? It looks like it is being reduced by a half every way, all the way down. So -0.5 or -0.5, and so on and so on. So I have to put in the numerator a -0.5. -0.5 over 1 is simply a -0.5 or -1/2. Okay, so this is a rate of change that is negative. All right, and as you can tell, if you were to plot these again, this would plot up as high as 4 over 1 and up as high as 4.5, and the last dot went all the way over to 6 and only went up as high as 2. The line is going downhill, hence the negative slope. All right, let's look at this one. Got our x's, got our y's. How is x increasing? By +5. What's y doing? It is decreasing, correct me, right? This is going down by -10, -10, -10, and so on. So the change in y over the change in x, and I simply get on this side, the change in y is a -10. The change in x is by +5, but that would be simplified out to be -2. So that's one way of looking at a set of values and determining if you can come up with the slope or the rate of change of the item. Whatever it is, there could be stories to these word problems. This one, the one about the car wash, was a story, but basically that's just taking a table of values and trying to determine the slope. You will be doing many, many, many of these. Okay, let's go to the next page. All right. Example 6. Find the slope of each line that passes through each pair of points that lie on the line. Okay. I have discussed numerous times now the change in y over the change in x. And I would like to show you a formula in which you can figure that out, given 2 points. Okay, slope is represented in algebra and going forward with the letter m. And I don't know why, it has something to do with some of the Greek genius. Change in y. How do we determine the change in y? Well, the change in y is taking the y value, y2, the y value from the second point, and minusing the y value from the first point is on top. And then do the same exact thing in the bottom. The x value from the second point, okay, minus the x value from the first point. Okay, this is the exact same thing as me saying the change in y over the change in x. And let me demonstrate. Okay, so if 3, 5 is 0.1 and -2, 10 is 0.2. So 3, 5 is the 0.1. We're going to call that x1 and y1. So the x from 0.1, the y from 0.1. The second point, so this is the first 0.1. The second point, or 0.2, okay, happens to be negative 2, comma 10, right? This is going to be the x from 0.2, and this is the y from 0.2. We all agree? Okay, so in keeping with my change in y or change in x, the mathematical equation is m equals y2 minus y1 all over x2 minus x1. So now I'm going to plug in those numbers and do the math. y2 is 10, the y from the second point. So 10 and 5 are the y's. How did it change? That's easy. 10 minus 5, we know it changed by 5. And the math behind it is 10 minus 5. Okay? Over x2 minus x1. x2 is a negative 2, and x1 is a positive 3. So I go minus positive 3. This minus makes the 3 now a negative. That's something to keep in mind. In other words, how did we get from this point is negative 2, but it started out at 3? So let's think about that. What was that change? So negative 2 and minus 3. The top number becomes 10 take away 5, simply 5. These two together make negative 5. So my answer here is 5 over 5, which is 1, but one of the numbers is negative, therefore the slope is a negative 1. Okay? And again, if you were to picture this on a number line, where is on a graph, where is 3, 5? 3, 5, let's say, is something somewhere over here. Let's see here, this is 3, and 5 might be here. And the other one was negative 2, 10. Well, negative 2, 10 is something like way over here. This line's clearly going downhill. It is a negative 1. Okay? So let's keep this formula in mind. Super, super, super important. You will memorize this, all right? Change in y or change in x. What does that come out to be? y2 minus y1. And this is not squares. These are locations on the graph. The y from point 2 minus the y from point 1 over the x from point 2 minus the x from point 1. And that gets you your mathematical change in y over change in x. Okay, so let's take a look at this. This is x1, this is y1, this is x2, this is y2. So if I'm filling in my formula, m equals y2 minus y1, and notice I'm writing it out, so I'm not going to make a mistake. So right next to it, I put the numbers. y2 is 2. Oops. So I wrote it out the formula, okay, and I'm taking the numbers from the two coordinates. This is the 0.2, this is 0.1. So 2 minus a negative 1. You must remember this minus is part of the formula. Must be there. So 2 minus a negative 1 over the x1, 3, minus a 2. Now just do your math. Double negative, that becomes positive. So on top I get 3 over 1. My final answer is 3. The slope between these 2 points would be 3, or 3 over 1. This is the rise and this is the run. So between the line it would run 1 box and it would go up 3. Okay? Let's try this one. I'm going to write the formula again. M equals y2 minus y1 all over x2 minus x1 equals. Do the math. y2. This is 0.2 right here. This is y2. 1 minus 2. Okay? Again, remember, this is x1, this is y1, this is x2, this is y2. So 1 minus 2 over x2 is 1 minus a negative 1. Okay, so up on top, I now have a negative 1 over, double negative makes positive, 1 and 1 makes 2. So my slope here is a negative 1/2. My rise, I would be rise over the run, okay, in the same words, change in y over the change in x. So this line's going downhill, okay, it goes down by 1 unit, but it runs over 2 units. And we'll see that on a graph shortly. Okay, want to try C by yourself? I will write the formula to get you started. M equals y2 minus y1 all over x2 minus x1. Are we there? So, remember, this is x from point 1, y from point 1. This is x from point 2. This is y from point 2. So I start with 4 minus 8 over negative 4 minus another negative 4. What do I get on top? Negative 4 over, remember this makes positive, over 0. Can we ever divide by 0? No. Therefore, this is a line we call undefined. If you remember from a couple of pages ago, has no slope. It's called undefined. Can't divide by 0. Let's look at this on a graph. If you were to graph these two coordinates, negative 4, 8, negative 4, and up to 8, about there. Negative 4, 8. Right? What's this one? Negative 4, 4. Oh, negative 4, 4. It's got to be right there. Negative 4, 4. So, what's this line doing? It's a perfectly straight vertical line, hence undefined. Okay? All right, let's try the last one. Again, m equals y2 minus y1 all over x2 minus x1. So do the numbers. Put the numbers in. And I am not going to label. You now know this is 0.1, this is 0.2. So I go negative 7 minus, minus another negative 7. Interesting. And the x's are negative 2 minus 5. What do I get on top? This makes plus, that's a negative. So I get 0 on top this time. And on the bottom, I have a negative 7. A 0 on top with divided by negative 7, if we think about this, has the value of 0. 0 divided by negative 7 makes 0. And the reason is if we go and graph this one, okay, 5, negative 7, over 5, down 7. So I would say about there. 5, negative 7, about there. Negative 2, negative 7. Well, guess what? It's a flat line. -2, -7. So these two actually are, it's a flat line and it has the slope of 0. Okay, and just doing the math, we came up with that. The slope of 0 means it is a flat line. If you end up dividing by 0, it's called undefined. There is no such thing. Okay, to finish up, the next page is everything we just learned. Okay, this is a study page. It's all the notes that I just basically taught you. Okay, this is the definition for change in y. And the change in the y coordinates over the change in x. The only thing you don't have here is the actual formula written, and I will give it to you right now. y2 minus y1 divided by x2 minus x1. Okay? That's called the slope of the line. It's also called the rate of change. You will see this in word problems and as well as some graphs. Possible graphs you may have: positive slope, meaning the line is going from left to right, going uphill. A negative slope would be going downhill. Okay? A 0 slope is a flat line. A perfectly straight vertical line is what we would call undefined. Okay? Parts of a linear equation, we just talked about the slope. The slope is also called the rise over the run. And again, what I've said now many times, the change in y over the change in x. And change, this is the symbol for change in y, I think it's called delta, and change in x. And it's a Greek symbol. Change in y or change in x. So this is nothing, this whole page is just a study page. And I think you got that.